Now in this part of the question we're asked to work out the bearing of C from B, and that angle is the angle theta degrees. Now in order to work that out, what I'm going to do is work out what the angle here is, which I'm going to call alpha. And once I've got alpha, I can take it away from 180 degrees and get theta. So how do I get alpha? Well, what I've got is, in my triangle, a situation where I have got the opposite side to alpha, that's the 700 meters, and I've got another side, BC in this case, and its opposite angle 15 degrees that I know. So this is typical of the sine rule. So I'm going to use the sine rule for this one. So we have the sine of the angle alpha over the opposite side, which is 700, is exactly the same as comparing the sine of another angle, in this case sine 15 degrees, with its opposite side. And the opposite side to sine 15, or to the 15 degrees I should say, is BC, and that is 252.689 and so on. That was what we had in the first part of the question. And be careful, don't use 253, the rounded up version, because if you do, the chances are you'll have an inaccurate answer at the end. So to work out sine alpha, I just need to multiply both sides by the 700, so we have 700 multiplied by sine 15 over 252.689 and so on. And if I work that out on a calculator, you find that you get 0.71698. Okay, and then to get alpha, all I need to do is the inverse sine of 0.71698, and doing that, what comes up on the calculator is in fact 45.8057. Now when you look at the diagram, you can clearly see that alpha is more than 90 degrees. It's an obtuse angle. It cannot be the 45.8057 degrees basically. So why is this? Well, cast your mind back to the quadrant diagram for instance. Remember that if this is 0 degrees, sine is positive. Okay, positive because we're dealing with 0.71698 in the first quadrant. All trig ratios are positive in that quadrant, and sine is positive in the second quadrant. So if I mark two lines like that and mark in these two angles always to the horizontal, which are the same, then when I do the inverse sine of 0.71698, I can expect to get either this angle, or between 0 and 180, another solution is this angle round here. Now clearly the calculator is giving us this angle in here, this acute angle of 45.8 degrees basically. So that means this angle over here is also 45.8 degrees. So essentially, to get the obtuse angle round here, which is the angle alpha that I'm really looking for, okay, then I've got to do 180 degrees minus the 45.8057. So therefore the one that I'm really interested in is 180 minus that, which comes out at 134.194 and so on degrees. So this is the alpha that you see in the diagram. So to get theta, okay, theta must be equal to 180 degrees take away alpha. 180 degrees then take away the 134.194 and so on degrees. And you'll see that that in fact is the 45.8057 answer. Now bearings are normally quoted by three figures. We often say a bearing is a three-figure bearing, so we would therefore have theta equals 046 degrees if we give it as a three-figure bearing. Alright, and that brings us now to the end of this question.